This is Professor Teresa Pelkie. This is Session 10, Part 1, Left Joins. In this session, we'll continue looking at how to create joins in SQL. In Part 1, we'll work with left joins. Using a left join, you can join two or more tables and get data in the result set, even if there are no matching values in the joined tables. In Part 2, we'll look at some other less commonly used types of joins. To get started, we'll import a new schema into MySQL Workbench. The new schema that you'll import is the college schema. It contains definitions for some tables, and it also contains sample data in some of the tables. As you'll see, the tables in this schema can be used to learn about left joins. Locate the college.SQL file in the course materials. This is really just a text file, and you can open it in any text editor. Go into the MySQL Workbench if you are not already there. On the File menu, click the Run SQL Script item as shown in the left figure on this slide. Although this slide shows screenshots from a Windows PC, the Mac version of the Workbench uses the same menu items, so you can use these steps on a Mac also. When you click the Run SQL Script item, you'll be asked to select the script file to run. Navigate to the college.SQL script file that you downloaded and select it. After you select it, you'll see a window like what is shown on the right side of this slide. The top part of the window shows the statements that are in the script file. The bottom part has two entry fields for default schema name and default character set. Don't enter anything into either of those fields, just click the Run button. When you click the Run button, the script will start running. You'll see another window open as shown on the left of this slide. When the script is done running, you should see the Operation Completed Successfully message, as shown here. When you see that message, click the Close button to close the window. Now go to the navigator as shown on the right. Click the refresh icon, which is circled on the top right on this slide. When you refresh the schemas list, you should now see the college schema. You can expand it to see the tables that are in the schema as shown in the figure on the bottom right. Finally, right-click on the college schema and click the Set as Default Schema item from the pop-up menu, as shown on this slide. Remember, if you have set a schema as the default schema, you don't have to schema qualify the table names in the SQL statements that you write. If you do not set a default schema, then you need to put the schema name as the first part of the qualified table name in your SQL statements. So let's start working with the data in the college schema. The first table we'll look at is the members table. This table contains data about students who attend the college. As you can see, this is simple name and address data along with the birth date, phone, and email address. The student ID column is the primary key for this table. It contains a unique integer identifier for each row in the table. The advisor ID column is a foreign key. It is the ID of an advisor in the advisors table. Some of the members have been assigned an advisor, so you see an integer value. For members that have not been assigned an advisor, the value of the column is null. The next table we'll look at is the advisors table. This is a simple table containing a unique advisor ID, which is the primary key for the table. It also contains the advisor title, first and last name, their room at the college, phone number, and email address. The next table is the scholarships table. This is another simple table containing a unique scholarship ID, which is the primary key for the table. Note that this column is defined as a character data type. It also contains the organization that is granting the scholarship, the amount, semester, and the year. The final table is the scholarships students table. As you can see, this is a very simple table. It does not contain any real data. Instead, it points to data in the members table and the scholarships table. In this table, the ID column is the primary key. The scholarship ID column is a foreign key. It is used to link the scholarship ID column in the scholarships table. The student ID column is also a foreign key. It links to the student ID column in the members table. Note that it is possible for a student ID to appear more than once in this table. That means that the student has more than one scholarship. It would also be possible for the same scholarship ID value to appear more than once, meaning that the same scholarship was awarded to more than one student. So let's see how we can work with these tables using the inner join technique that you have learned about in the last session. Look first at the from clause where we specify the members table with the table alias value ME. Following the from, the first join clause specifies the scholarships students table with a table alias of SS. The on clause joins data in the scholarship students table with data in the members table when the student ID values in each table are a match. The second join clause specifies the scholarships table with the table alias of SC. The on clause for this join uses the scholarship ID value in the scholarship students table and in the scholarships table. When you specify just the keyword join, SQL interprets that as being an inner join. It would be correct to code the word inner before both of the join keywords. In actual practice, most SQL developers omit the inner keyword. Keep in mind that an inner join is used to get data in related tables when there is a match, as specified in the on clauses. So in this example, you see the students who have been awarded at least one scholarship. The column list at the beginning of the select statement specifies the data that is to appear in the results set. For the name column, we use the concat function to concatenate the last name, a comma and a space, and the first name. We assign the column alias value name to the result of the concat function. You'll also see the name column appearing in the order by clause, so that the data in the result grid is shown in order by last name. The other columns in the column list are from the scholarships table. You can tell that because the column names are preceded by the table alias SC. Note that none of the columns in the scholarship students table appear in the column list. You don't see any columns with the SS table alias prefix. It is perfectly valid to write SQL select statements that work with data in multiple tables but do not specify columns for a table in the columns list. Here's another example of the inner join select statement. This statement produces the same results that you saw on the previous slide. The result grid contains all of the students who have been awarded at least one scholarship. The difference between this select and the one on the previous slide is that the from clause now specifies the scholarships students table instead of the members table. This shows that for an inner join, the table order really doesn't matter. The reason why it does not matter is because you will only get data when there is a matching value found in each of the tables in the inner join. Now we'll look at a new type of join called a left join. I'll explain why it's called that later. For now, start looking at the result grid shown on this slide. You see that it lists the students. Some of the students have scholarship information and some do not. So right away, you can see what the main difference is between an inner join and a left join. The inner join only shows data if there is a match between the tables. The left join shows all data, even if there is no match. Now look at the select statement itself. This is the same select that was used on the first inner join example that I showed you a few minutes ago. The only difference is that I added the word left before the two occurrences of the word join. Technically, this type of join is referred to as a left outer join. And in fact, you could write the select statement using those three words. Again, most of the time, you'll simply see left join with the outer being implied. When you create a left join, the order that you specify the tables does not matter. A few slides back, I showed you two variations of the inner join where just the join keyword was used. With that type of join, it didn't matter which table was used in the from clause and which was used in the join clause. With a left join, it does matter which table you put into the from clause and which you put into the left join clause. You can think of the table in the from clause as being the primary table in the select. The table that you use in the from clause is the one that you want to see all the data for, whether or not it has any corresponding data in the tables that are specified in the join clauses. Let's look at a left join in pictures. This might help to explain why the term left join is used. Starting at the left side of the slide is the members table. The columns that are defined in the table are shown along with the data types. The members table is the table that is specified in the from clause, so it is considered to be the primary table in the join. The scholarship students table is in the middle. It is joined to the table to the left, the members table. The type of join is specified as a left join. The on clause specifies that the student ID column values in the members table and in the scholarship students table is used for the join. Because left join is specified as the join type, you will see a row in the result grid for each row in the members table, whether or not there is matching data in the scholarships students table. The scholarships table is on the right. It is joined to the table to its left, the scholarship students table, on the scholarship ID value that appears in both of the tables. Again, because left join is specified as the join type, there will be a row in the result grid whether or not there is a row in the scholarships table that matches the scholarship ID value in the scholarship students table. If you will be creating a select statement from scratch, you might find it useful to make a diagram like this. Start the diagram by placing the most important table at the left. The most important table is the table that contains the data that must appear in the result set. You then decide which type of join you need. Do you want all of the rows in the leftmost table to show up in the result set, whether or not there are any matching rows in the join tables? If you do want all of the rows to appear, then you join the tables using a left join. If you only want joins in the leftmost table to show up when there is matching data in the join tables, then you join the tables using an inner join or just the join keyword. Now we'll look at what happens when you combine the inner join with the left join. We'll be working with the same column list and tables for the next few slides. Each slide will have a variation of the join type. To get started, this select uses a left join for all four tables in the college schema. As before, the members table is the primary table. We start with a left join to the advisors table. That means that we want to see all member rows and their advisor if they have one. If they do not have an advisor, then null appears in place of the advisor name. We also use a left join to the scholarship students table. That means that we want to see all member rows and their scholarships if they have any. If they do not have any scholarships, a null value appears in place of the organization and the amount. In other words, this select is showing all of the rows in the members table and all of the additional data for advisors and scholarships if there is any. As you can see, some members have an advisor but no scholarship. Some members have a scholarship but no advisor. One member does not have an advisor or scholarship, and one member has both an advisor and a scholarship. Now let's look at a variation. In this variation, we change the left join on the advisors table to a join. We leave the left join for the other tables. The result set now includes only members that have an advisor. The members may or may not have a scholarship. In this example, the join on the advisors table has served to limit the members to only those with an advisor. In this variation, we change back to a left join for the advisors, and we change to a join for the scholarships students table. So now we get only members that have a scholarship. If the member has an advisor, it is shown. If not, the advisor name value is shown as null. The join on the scholarship students table limits the members to only those with a scholarship. For the final variation, we'll change all of the joins to just join. In this example, members are shown only if they have both an advisor and a scholarship. So what you can see from these examples is that the type of join can be used to limit the rows that are included from the table specified in the on clause. When you have multiple joins in the same select statement, you can think of the process as creating a subset of the primary table, then further subsetting that subset with the join tables. If the join type is left join, then data is included in the subset even if there is no match. If the join type is join, data is included in the subset only if there is a match. You may want to review the slides and analyze for yourself how the results are obtained. As you can see, there is no best type of join. You select the type of join to use based on what you need to end up with in the result set. Keep in mind when you use a join or left join, you can also use where clauses to limit the rows that can be used in the join. The where clause selections are processed before the join or left join operations. You can also use group by and having clauses in conjunction with join and left join operations. When you use group by and having, the join operations are processed first. Then the group by and having are processed using the result of the join. As usual, the order by clause is processed after all other operations. When the final results are available, they are then put in order using the order by clause. In the next video, we'll look at some of the other types of joins that are available in SQL. These include right joins, full joins, cross joins, and self joins.